Hello everyone, I am Priyanshi Korwal and today we are learning the Banker's algorithm of operating system. So first we see the introduction, deadlock and avoidance. Okay, deadlock. First we understand what is deadlock. So deadlock is a situation where a process where the two or more than two processes are simultaneously waiting for OS to free and to get OS basically. When if there is two process P1 and P2 and P1 get executed, not come but P1 are on running, but before completing P1, P2 get the OS, and before completing P2, P1 get the OS. So this loop is continuous, and because of this, deadlock causes, in which it causes a busy OS or system utilization is not occur here. Why we need deadlock avoidance? Obviously, we want to prevent deadlock condition. We want to be very safe. We want to in a safe state. We want to utilize our OS or system more, so we are using this. I'm so sorry. Okay, so what is Banker's algorithm? Banker's algorithm is proposed by Dijkstra. Okay, and Banker's algorithm is basically the combination of uh, Banker's algorithm is basically the combination of stage algorithm and resource request algorithm. And in Banker's algorithm helps prevent deadlock by requiring prior knowledge of processes and resource demand. On the basis of resources and demand, operating system use this information and decide whether which resource is going to which process. Algorithm evaluates if a safe sequence of process execution exists by the simultaneous resource allocation. And basically Banker's algorithm क्या करता है कि जैसे मैंने बोला अभी आपको कि लाइक before the execution or process come into the OS, it has all the demands and resource demands and knowledge of the process. So it decided how and which process allocated to which resources. Basically this is the Banker's algorithm. What is the purpose? Obviously it system always in the safe state. It's the purpose prevent circular wait condition. What is the circular wait condition? It's normally called deadlock or nothing. Okay, let's see the key concept. Safe state. What is the safe state? Safe state is the state when all the process are finishing completely, and then the OS goes and then the OS gives resources to the other process. Okay, and what is unsafe state? Yeah, any process is not running completely and the OS goes to another process without completing the before ones. Okay, हाईलाइट्स क्या है हमारे इसमें? तो Banker's algorithm अवॉइड करता है डेडलॉक को. इट रिक्वायर्स प्रायर नॉलेज ऑफ मैक्सिमम रिसोर्सेज फ्रॉम ईच of safe allocation decision. Okay, Banker's algorithm have mainly 6 prerequisites. That is allocation, availability. Okay, second is availability, first is allocation, third is maximum allocation, fourth is need, fifth is work, and sixth is finish. So what we are see in this concept are the system. We will see how these prerequisites work. Okay, the system the system stimulates resources allocation and release to find a safe sequence that prevents deadlock. If no process remaining needs can be fulfilled by available resource, the system is in an unsafe state, deadlock. The Banker's algorithm is primarily taught for academics and competitive exam purpose as real world. Okay, so we know that Banker's algorithm is a very basic algorithm, so it's not used in real world as usual, because the real world problems are very dynamic, so that's they are not used here. Okay, key concept and resource allocation. Let's see key concept. What is the key concept? Resource allocation. What is the resource allocation? Resource allocation is decided on the basis of resource demands, and Banker's algorithm carefully manage resource allocation to ensure a safe state. Okay, so let's see the working of Banker's algorithm. That is the most important topic in this. Okay, so there are total 4 steps. Process request for resource. Okay, if process request to resources, then it's the first step, and if the request can be granted without entering on the unsafe state, we want to check it. Okay, and then step 3, if safe allocation resources, otherwise deny the resource. if allocation resource safe है, then only you can go ahead, otherwise the request denied. Repeat until all processes are completed or resources are exhausted. Okay, so here's the written that why Banker's algorithm called Banker's algorithm, because it works like a bank system. Okay, the bank system in which the bank is OS, loan is resources, and customer is processes. Let we understand, वही कस्टमर को वही प्रोसेस को रिसोर्स मिलेगा ओएस के थ्रू जिनका रिकॉर्ड अच्छा हो. इट मीन्स कि जिनकी मतलब सेफ स्टेट जो है, जिनकी स्टेट जो है वो सेफ होगी, ओनली दोज प्रोसेस आर गेट रिसोर्सेज बाय ओएस. ओके, सो दैट्स कॉल्ड एन वर्किंग Banker's algorithm. The structures, so we will discuss these 5 prerequisites. So these are the 6 prerequisites. These are only 5 but okay. So here's one problem I will tell you. Okay, available is 1D array showing how many resources of each type are currently available. Okay, max. What is max? Max is a 2D array in which we store the maximum allocation capacity. Allocation. This allocation is used like how much allocated till now. And what is the need? Need is the basically the maximum allocation minus allocation. What is finish? Finish is the Boolean data type in which the true or false are stored. And there was one more, that is work, which is temporary copy of available. Let's see the algorithm steps. Okay, what is the algorithm steps? Okay, let work is equals to available and finish I is equals to false for all process I. Find an I such that finish I is equals to false and need I is equals to smaller than work. It means if finish is equals to false and need of I is smaller than equals to work, then only we will go ahead. And if no such I exists, to go to step 5. And if exist, then we will do work is equals to work plus allocation and finish is equals to true, and go to step 2, and we will do it repeatedly until the processes are not executed or get as access. Okay, these are the essentials diagram. You can also learn it. This is the important, I think so, Banker's algorithm flowchart. My god, guys. Okay, so there was a resource in which go down which go here, resource availability. If resource is available, then it go to secure state. If not, then it go to wait or rejected. The things goes to wait or rejected goes to queues, and first come first services apply, and it get the resource granted. But what if available? Okay, so secure state, if say yes, then resource was allocated, and if it says no, then the same process wait or rejected, then queue, and then process execution occurs. So this works like this. Okay, so let's understand the Banker's algorithm simple example. So this is the example in which three states three resources and three processes are running, and here's the allocation graph in which P1 is equals to B1 हो गया, and P0 is equals to B1 हो गया, P1 is equals to A2 हो गया, and P2 is equals to A3 हो गया, और C2 हो गया. Okay, we know that need is equals to max minus allocation. safe sequence check. So safe sequence check हम कैसे करेंगे कि इफ़ कोई प्रोसेस अच्छे से रन हो रही है, कम्प्लीटली रन हो रही है, एंड देन दूसरी प्रोसेस स्टार्ट हो रही है रन होना, देन इट इज़ कॉल्ड सेफ सीक्वेंस चेक. एंड जो अवेलेबल हमारे पास मार्जिन है उसके अंदर ही आना चाहिए. लाइक P1 नीड्स 1,2,2 एंड इट्स अंडर द मार्जिन 3,3,2, एंड P0 नीड्स 7,4,3 that is not under the margin, and 6,0,0 it's also not in the range. So these are unsafe, and P1 is safe only. Advantages. So let us understand what is the advantage of deadlock. By carefully managing resource allocation, provides maximum resource utilization, predictable resources allocation. What is the disadvantages? Obviously can lead to lower resource utilization in some cases. If there was very much amount of processes, then it can lead to lower resources, and it can maybe slower or okay. And then overheaded of constant checking of because we are checking if process have not safe state, then we are checking it again and again after every process, so it may cause overhead. That is not good at all. While not directly implemented in its pure form due to the needs for prior knowledge, Banker's algorithm principle are used. Resource management in database system, job scheduling in high performance computing environments, embedded system with critical resources allocation. Okay, now we are at our conclusion and conclusion. And Banker's algorithm is a valuable tool for understanding deadlock advances, because it is easy and we can easily understand the deadlock avoidance with the help of Banker's algorithm. Okay, it provides a framework for safe resource allocation in operating system. Understanding its principle help in designing robust, reliable and systematic conclusion. Basically the Banker's algorithm works on some process are coming, is it completely running, and if it completely running, then only we will give it a resources. Okay, if deadlock doesn't occur, then only we will give it the resources, unless we are not giving the resources to them. Okay, so that's all about the Banker's algorithm. Thanks for watching. These are the references what we use in the PPT, and my god, PPT, I'm so sorry.